Welcome to SBME Interfaces. Our goal with this show is to introduce you to the people that interface with biomedical engineering, from students and faculty to staff and industry, and everyone in between. BME is a broad field that encompasses so many different perspectives, journeys, skill sets, and backgrounds, and we are excited to share them all with you.
Today we're interfacing with Karen Cheung. She's a professor in the School of Biomedical Engineering and the Department of Electrical and Computer Engineering at UBC. She also directs the graduate program in the school and is also associate director. She received her undergraduate and PhD degrees in bioengineering from the University of California, Berkeley, and did her postdoctoral fellowship at École Polytechnique Fédérale de Lausanne in Switzerland. Her research interests include lab on chip systems for cell culture and characterization, inkjet printing, for tissue engineering, and implantable neural interfaces. Welcome, Karen.
Thank you for having me.
So we've seen all the stuff that you're doing, which is a lot right now. But the thing that really interests me is over the past 14, 15 months, how has that, like the pandemic in general, impacted the graduate education program, and sort of how have you had to pivot?
There was a huge impact. UBC told us that all the labs were shut down and everybody had to go home and work from home. And that's a big change for a lot of grad students who depend on working in the laboratory with the instruments there. So lots of graduate students had to find other ways to include elements like modeling or more data analysis. And it's been really stressful for students in that way. It's also been very challenging in that we've had new international students who had big difficulties in arriving in Canada with the visas and the travel restrictions. And that's been a huge topic of our discussion. So ever since the pandemic, we've had weekly and then bi-weekly meetings with all the other graduate program directors and grad studies to work through these issues of bringing in new students and helping to support our students who are going through this really stressful time.
Mm-hmm.
So I'm really thankful for all the research supervisors who have been able to support their students in pivoting their projects. And everybody's been very understanding in that the graduate programs or degrees are taking longer than originally envisaged.
Yeah. Can you talk about how it's impacted your research as well?
Likewise, our own research group, it depends on the students being in the lab. So we pivoted as well. Some of my students incorporated more modeling aspects into their work, did more analysis of the images that they already had. But the funny thing was that, right when the pandemic started, my colleague Lucas Krastowski and I have been working on a project in silicon photonic biosensors for a long time. For 10 years or so. And it's always been an unfunded project, kind of like we had a student, but we just kind of peeled off little bits from here and there. But right at the beginning of the pandemic, there was a company that was looking for a way to validate their technology for detecting COVID. And since silicon photonic biosensors are scalable technology, we know we need lots of these kinds of tests. Then this project really got going. So we got an exemption from the university so that we could get back in the laboratory. And my student who was working on this also pivoted, but due to his expertise in doing these immunoassays and things, it was just really exciting to be able to contribute in that way. And due to the pandemic, then we were able to actually get some funding related to this project for the first time ever. So that's been exciting.
That is.
It's a nice silver lining for sure. So taking a step back, what led you to a career in academia?
When I was in high school, I thought, wouldn't it be great if there was a neural probe that could help me convey my thoughts? Because I had trouble explaining myself in words. So I thought, what if we had some technology that could directly convey what I was thinking to my interlocutor? And so that's how I got into grad school, thinking that we could develop this kind of technology to help people communicate. And from there, looking at neural interfaces, and I ended up doing a postdoc in Switzerland. At the end of my postdoc, I was looking around for where I was going to go next. So I never thought I was going to end up in academia. When I was in grad school in California, I remember going to these panels where there would be scientists at companies telling us that they would work on the company projects, but they would also have the opportunity, some fraction of their time for their own projects. And I thought, that's the job for me. But then at the end of my postdoc, I was looking around at company listings, and I thought, but they have very interesting projects. But as a postdoc, I was able to work on a number of different projects. So I got to appreciate the kind of freedom we have in academia to pursue the projects, the ones that we can get funded. And so that's how I ended up in academia.
That's interesting. This tracks to the next question, which is like you're the director of the SBME Graduate Program, which means you've taken that and like to the next level. Can you expand a little bit on what your role is as the director of that program?
I've been grad advisor since 2015, since before the establishment of the school. And when the school was established, I was invited to take on this new role as director of the grad program. So as director of the overall graduate program, I look after all of our now 120 graduate students in the MEng, the master's, and the PhD programs. And so in this role, I work with colleagues to look at awards and scholarships. So students apply for these scholarships and we have to adjudicate them in the university and in the national competition. I look after admissions of new graduate students to our programs. And I've had the opportunity to work with a team of colleagues to establish a new curriculum. And it's been exciting to launch a new PhD rotation program. So this is totally new, and bringing in students who have the opportunity to check out a few different laboratories before they settle into one for their PhD thesis. So those are some of the things that we do.
You do way more than that, I know, but we're glad to have you on board. So, I mean, you alluded to this. UBC had a BME program. 2017, we established a school. You've been part from the beginning. What excites you about the school now, and where do you think it can take us?
What's been most exciting about the school is that it was kind of established de novo. We got to recruit new faculty members. We got to establish what our culture is going to be. So we're not weighed down by decades of history of, oh, this is how our department has always done things, and so we're going to do it that way and have to change a little bit at a time. But we get to actually choose what we like the best from how other departments do things. We like this aspect, we like that aspect, and we can choose what works best for us as we're building this new school. And that's been the most exciting, I think.
Absolutely. Some of the Masters of Science and PhD level courses, the foundational ones, we've got one focused on the broad BME topics and one on professional academic development. What do you think is important about these types of courses, especially the professional and academic development ones?
The new core courses, those are required for all of our MASC PhD students. And they are important for different things. One of them, the core course that is co-taught by faculty members with complementary expertise, is really providing breadth, because we know the students are going to gain depth through their thesis work. They're going to gain deep technical expertise, and we know that that's important for making impactful, deep contributions. But breadth is also important because biomedical engineering is really interdisciplinary. And when we look at big institutions, whether they're universities or companies, it's breadth that really allows people to connect with other team members. And when we look at the kinds of contributions made by people with either depth or breadth, they're important. But what we really want are the polymaths who actually have deep expertise, but can then continue to apply that to other fields, other teams in the same institution. And that really brings value, whether it's a university or a big company. Those are the people, the polymaths, who bring the most value to the institution. And so as students are certainly going to gain depth, they need that early in their career. But we know how knowledge works, that it's flexibility of knowledge and how you make linkages that's important later on in their careers. So that core course, I hope, is going to establish a culture of, welcoming breadth, that's going to be very useful for them as they advance in their careers. The second core course in academic development and what is this academic enterprise is also important, because it's giving them skills in communicating, and that is so important nowadays, being able to convey your expertise not only to fellow scientists and technical experts, but also to the public. So I think that both of these packages are very important for all of our graduate students.
And I think breadth and depth are key to breaking down the historical academic silos, because depth creates silos, but breadth breaks them apart. So that's great we're doing that. We had a chance to speak to a couple of our teaching faculty a couple episodes ago, and we posed a version of this, but we're just wondering, how do you foresee, or do you foresee changes in graduate program delivery due to what we've gone through now through the pandemic for almost 15 months?
Obviously, if we are able to deliver online courses, as we've had to do in the past year, then in some respects, we should take advantage of that going forward. So we know that there are fantastic courses offered by experts at UBC. Why not have U of T students be able to take those too, so that we can build a bigger network, or students from McGill or from Calgary. And likewise, our students should be able to take a course offered at U of T. So, the courses are taught by the experts, and the instructor is then on the hook to actually teach you. So everybody should be able to benefit from that. The students will be able to build a bigger network of other trainees across Canada. And, if we have our courses offered more widely, then people can see better what UBC has to offer. So I hope that will change and become more permanent going forward.
I love that idea. I went through the University of Calgary, and I finished my degree at UBC, but as a visiting student. But the hoops I had to jump through to make sure that the programs were talking to each other, and that sort of thing it was a big deal. So I like this. I like the idea of connecting a university network of BME courses. It's really cool. So providing students with balanced exposure to research, courses, internship opportunities, professional development, we know that leads to well-rounded graduates. I think you and I have even talked about that before. Are there any aspects to this rounded experience that you would like to see expanded for our graduate students?
Our students definitely get a lot of training in scientific writing and scientific communication, and I would like to see even more emphasis put on communicating with other audiences. So communicating with the public. It's becoming so much more important now to be able to communicate with non-scientists, because biomedical engineering is really central to grand challenges in health, of course, but science and engineering are also going to be essential for challenges in sustainability or climate change, economic productivity. So effectively communicating our work, it's not just helping people understand the benefits of what we do, but also if we're able to frame some of the risks and costs of decisions that can help everybody make better decisions. And certainly we need to share our findings, not only with the public, to generate excitement about science and bring in more people into science and engineering, but we need to, I think, be able to influence public opinions and government and policy and generate more support for science and engineering. So that's where I think it's really important to be able to hone our messages, to ask ourselves, what's really important here, and how can I make that point in a way that's speaking to intelligent people, so we're not dumbing anything down, but making it more understandable.
I'll let Miguel take the next question. I'll jump one. So you're a big advocate for women in STEM, and Can you speak to some of your work in this area and a little about your nomination for the is it YMCA? Should that be YMCA?
YW.
YWCA award.
I've been honored to be invited to speak on some panels about women in science or women in academia. I always feel like I'm not really sure what I can contribute to these kinds of conversations. These kinds of conversations have been happening for decades. But more recently, I guess, from what I see, it's also important just to share our experiences. So being on these panels and being able to answer questions and sharing what I've found, things that I really didn't know when I started my job in academia, but I found it, but I can tell other people so that they can see, they have more information. I really wish I had answers at this age, but I think what I could do is actually just show people, tell people what I've done, and then they can ask other people what other people have done. And from all of these possibilities, then choose what works for them or inform their own decisions. So that's some of the things I've been working on. I think that what I've also liked doing is being able to support our graduate students in participating in events such as the Science World. They put on an event for girls in STEAM, science and technology. And so we want to make sure that we support those kinds of events. Our graduate students make demos. I want to make sure we can give opportunities to our junior faculty members to also serve on panels and be mentors as well. I think that this kind of supporting other people to also be role models and examples is very important.
It's funny. I understand the feeling of like not being able to contribute to that conversation or wondering if you even should, but I firmly believe that what you're doing might have more impact, right? The idea of sharing your experience and demonstrating at the very least something that somebody can look at and be like, oh, like, yeah, me too. Like I can recognize myself there. I can see myself there. I'm a way bigger fan of, instead of having all the answers, of having a bunch of really great questions based on your experience. So I think that what you're doing has way more impact than you think.
Thank you.
Okay, so last year, this was really wonderful, by the way. Your research put you in a virtual room more than once with the Prime Minister of Canada over the past like 14 months or so. So what does it mean to you to have that kind of impact from your efforts and that of your collaborators?
Oh, it was so coincidental, so lucky that we were invited to be participating in these panels. One project was related to the silicon photonic biosensors because it could have applications for detecting COVID or other future infections of various kinds. The other time we were invited to speak with the Prime Minister was related to a project that's led by Sam Aparicio in cancer. So we're developing new technologies to do single cell measurements for understanding heterogeneity within cancer. I think it's really special that the government is taking the time to speak with the researchers and understand what's going on across Canada. So every day there's new funding announcements. And I think along with that, scientists get the opportunity to have this platform and explain a little bit to government and to the public what we're doing. And not every country does that, I think. So I think I really appreciate that here.
So just a question came top of mind about your research. I mean, I mentioned earlier on when I introduced you, you work in different areas. Can you give maybe a lay overview of some of the stuff you do, and beyond the single cell analysis and the photonics, what's other stuff that really excites you, keeps you up at night thinking about how to get grants and get the students to work on them?
One of our projects is related to organ on chip. And actually that's several projects. So we've had students working on making tumor models on a chip. So these are small scale microtissues that model the actual organ, but since they're small and we can control them, we can maybe make lots of them. And that'll be important for pharmaceutical companies when they're developing new treatments. So we have a project in tumor on a chip, or airway on a chip, and that'll be important for studying and developing treatments for asthma or chronic obstructive pulmonary disease. And another project in kind of brain on a chip, where we're making a model of the brain microvasculature that'll be important for studying what happens and treatments for neurodegenerative disease. And what keeps me up at night is convincing people that this technology, even though it has limitations, it isn't going to be a whole body or a whole organism, but it still has value in answering very specific questions. And so we're building that complexity step by step and showing that, well, it doesn't have everything, but it has enough to answer this question about how a tissue responds to changes in oxygen level, for example. And that has value. And the next time, then we'll add more complexity to it so that we can actually model more of the challenge. That's been one of our stumbling blocks, how to convey what we can do and the context and where we can go next with it.
Out of curiosity, what do you usually encounter? Like, what is it? Is it pushback? Is it misunderstanding? Is like what's usually the problem you encounter?
There's some pushbacks, like it doesn't incorporate the immune response, or it doesn't incorporate completely formed blood vessels, or all of these are very true because there's such an interplay between, you know, the different kinds of cells and other cells in these microenvironments. And yet at the same time, we're making progress. We're making scaffolds that support the cells. We're using new materials that actually better mimic what we see in the body, in the extracellular matrix, compared to what's been done before. So we have made progress in making models that have these kinds of materials, or the properties, mechanical properties that do model what happens in the tissue. And we're making progress in creating well-defined architectures for the blood vessels and co-cultures of the different cells. So it's not like it's not useful for anything, but we need to frame the questions of what we can do with the technology now.
I have another thing that I've been curious about is, you talked about one of the core courses the graduate student takes, which involves depth and breadth that can lead to sort of open-minded thinking, but we're a dispersed group, both on campus and then on the hospital sites. And so how do we, in your mind, especially in the graduate student grouping, build culture for them where they feel included within the SBME umbrella? Beyond just a course, I guess, or seminar series?
That was one of the goals of the courses from the program perspective, to build this kind of cohort cohesiveness. And the students, when they come in, they can see each other, and everybody's going to have a very different thesis project. But hearing students working in more machine learning aspects, or students working in more immunology aspects, then I can begin to see as a student then all the different diverse, you know, areas in biomedical engineering. They also have opportunities to build this cohort feeling through the Biomedical Engineering Graduate Student Association. They do activities there, so they get to know each other better there as well. And you know, students themselves have many initiatives. There are students who are interested in more of the science outreach, so they can work together in that way. Students whose own project is more in photonics or imaging are working side by side with students working in a totally other lab. So they have many opportunities to get to know each other and see that kind of breadth. Because, you know, when you go into a job interview, they're going to ask you about the job. And then what happens is they're like, oh, you work in biomedical engineering. So what do you think of this new, and whatever it is that was the news in the New York Times or the Globe and Mail, like, oh, okay, so what do you think about this new advance in single cell sequencing? Or what do you think about this new advance in imaging? And you can't have nothing to say because you're the biomedical engineer. So having at least some knowledge of like, oh, well, I think that you know, high throughput sequencing is very interesting because, and say something. I think that's very useful. That happens to me a lot. When I was an undergrad, I would say to people, oh, I work in bioengineering. And they'd be like, oh, but what do you think about implants? Like, I don't work in hip implants at all, but knowing a little bit about that, we can have a little bit of a conversation.
Yeah. Okay, with everything you've got going on, which is a lot, what do you do to recharge?
What's been fantastic during the pandemic is that it's been tragic that all these um, cultural and artistic institutions have been closed. But what the Metropolitan Opera in New York did was they started streaming all these operas every night. And so I've really enjoyed being able to catch some of that. So the number of times I've watched the first 30 minutes of something, and then like, okay, no, actually I have to get back to work and write this proposal or write this other thing. So I've caught the first half an hour of many operas.
I love that. If you have the opportunity, I highly recommend checking out the Van Gogh exhibit right now in Vancouver, the one that you can walk through all of the paintings.
I will.
It's really, really lovely what they did there.
Thank you, I will.
So another lighthearted question, piece of advice you would give to your 20-year-old self?
When I was younger, and I still think it actually, I thought that wisdom and answers would come with age. So I'm still waiting, but I guess, because I would have thought at that age, that by this age that I am now, I would have the answers. I would know what to do in all these situations. So I guess I would tell myself that it's not going to happen that way, but but it's still okay somehow. That we're going to find a way to get our work done and to make our way through life.
I love that. That's quite profound, actually. All right, so last question. Is there any particular initiative or project or endeavor that you're overseeing right now that you are very excited about and you think we all should get excited about too?
I'm really excited about finding ways to give more research opportunities to undergraduate students, because I think of it as a way to build a pipeline of strong applicants to grad programs. So it's been really exciting to work with staff in BME to flesh out this idea more, because students need to see what research is. Like, what is it? What does it mean to discover new knowledge and not just apply what's already known? So research to me is making new discoveries, expanding knowledge. And every summer we get fantastic undergraduate students from UBC in research labs. And we get students who might be enrolled at U of T or McGill, but they're coming back to Vancouver because their families are in Vancouver, they grew up here. And what I'm really excited about is finding a way to support other students who might never have thought about coming to BC or Vancouver. It wasn't on their radar. So they might need a little bit of extra support to explore and say, oh, I'm actually going to try out coming to UBC, doing research here. And then they'll see how fantastic Vancouver is, how great UBC is, and then it'll be on their minds when they want to go to grad school. So I want to find more ways for maybe industry partners or other ways to support this kind of program to bring in a more diverse population.
Love it.
That is a key thing, because you read everything's online now, but you need to experience to know what's going on.
Absolutely.
Thank you so much, Karen. It's always a pleasure talking to you and being open with us, and wish you all the best. And I know you're always going to be busy, but we need people like you to champion us and move us forward. So thank you again.
Thank you both very much.
Thank you, Karen.